These same steps for converting between units will allow us to convert units of volume as well. So let's practice a couple of problems with the volume. 5.2 liters over 1. I want liters to go away and milliliters to appear. It takes 1,000 milliliters to make a liter. I cross out my like units, and because I'm multiplying by a power of 10, my decimal is going to go 3 places to the right, making this final answer 5,200 milliliters. In this next example, I have 460 milliliters. This time I'm changing to liters. So I'll have the same units in my unit fraction, but notice that these two are upside down from each other because that's what allows me to cancel out these like units. So in this case, the 1,000 milliliters is going to go on the bottom and the 1 liter on the top. So this time I'm dividing by 1,000 instead of multiplying. So this decimal point, which is always at the end, if you're not told otherwise, is going to have to move 3 places to the left to become 4/600 liters. We can also use this same process even when there's a little bit of a context or a story here. Akiyoshi is a sumo wrestler and weighs 159 kilograms. And they want us to change this weight of kilograms into grams. So this problem is just like the ones above, where we're given an amount, 159 kilograms, and we're supposed to change it to grams. So my 159 kilograms over 1, kilograms on the bottom, I'm changing to grams. Well, it takes 1,000 grams to make a single kilogram. So I'm multiplying by this power of 10. That means the decimal is going to move 3 places bigger or to the right. So Akiyoshi weighs 159,000 grams. In this next example, we're talking about a chemist who has mixed 225 milligrams of sodium chloride with water, and they want us to change these milligrams into grams. So 225 milligrams over 1. I want the milligrams to go away, the grams to appear. The difference between a gram and a milligram, it takes 1,000 milligrams to make 1 gram. My units cancel out. I'm dividing by 1,000, so my decimal that's here at the end of this number is going to move 3 places to the left, leaving me with 225 thousandths of a gram. So there's something I want to mention at this point. Some of you may be really comfortable with the metric system or may have learned a method of doing these conversions just using a chart with the metric units. And while that system is fine and is something that will work in all cases, our science department has specifically asked us to teach it to you using these unit conversions because they're going to become part of a larger problem that we're using down the line. So just as it's been with many skills we've learned this semester, please practice doing the conversions using these unit fractions because this is just the beginning step of later steps that we're going to be adding on to this process. There's 2 other things that I'd like to share with you about the metric system. The first one in Objective 5 is just distinguishing between the different metric units. So remember, our metric units measure length with units that end in meters. They measure volume with units that end in liters. And they measure mass, sometimes called weight, in units that end in grams. So you're going to choose from meters, millimeters, centimeters, kilometers, liters, milliliters, grams, milligrams, or kilograms to determine which is the most appropriate unit. So the first one we're looking at is Jeanette, who bought 4 something of windshield washer fluid for her car. Because our item is fluid, I'm going to guess that this is one of our measures of volume. So I'm choosing between liters and milliliters. Now remember, a milliliter, there's 5 milliliters in a teaspoon, so she probably bought more than a teaspoonful of windshield wiper fluid. So I'm going to say that the appropriate unit here is liters, which would be close to about a gallon. Our cat weighs 5.4 something. Our units for weight or mass are grams, milligrams, and kilograms. And the gram is the paper clip. The milligram is just a teeny speck of a paper clip. So kilograms, if we're talking about a whole cat, is probably the best direction to go here. And for our final example, get one more color here. The wallet has a width of 18 something. And width would be a measure of length. So I'm talking about using meters, millimeters, centimeters, or kilometers. Well, kilometer is a big chunk of a mile. Don't think you could have a wallet that's a mile long that fits in your pocket. Millimeters are very, very tiny. If there was only 18 of those, the whole wallet would only be about that big. Meters, remember our unit for that is similar to a yardstick. Don't think you could have a wallet that is 18 yardsticks wide. So it looks like we're going with centimeters for that. One final neat trick to know with the metric system is that when we're using the U.S. customary system, that's the units with feet and cups and pounds, there isn't an easy way to translate between units or systems, to translate between length and volume and weight. So I want to give you an example here of a cube that measures 1 centimeter square. So that's measured in length. If you make a cube that is 1 centimeter square, its volume or the amount of liquid that it can hold happens to be exactly 1 milliliter. And if that milliliter was a milliliter of water, its mass or its weight would weigh exactly 1 gram. So, if you had a swimming pool on the roof of your house and you knew what the dimensions of the swimming pool were, how many centimeters long by how many centimeters deep by how many centimeters wide the swimming pool was, you could calculate how many milliliters of water it would take to fill it. And then once you knew the number of milliliters of water that were going to fill it, you could turn that into grams and then maybe even kilograms, since grams are a pretty tiny weight of a paperclip, to figure out how much that water that's on the roof of your house is going to weigh, which might be a handy thing to know before you start putting all that weight on the roof of your house.